If you're watching this video, I hope you already saw the first video, the selection sort example 1. This really is meant to help you prepare to answer questions about selection sort algorithm. You should have already done it hands-on so that you have some idea, because you will be getting questions on exams or quizzes that will ask you to tell me or to tell us what the list looks like at a certain pass or after certain passes. That'll make sense after watching this clip, but you should have watched and followed along with the first selection sort video where you're doing hands-on use of the algorithm, so this makes a little bit more sense. Okay, so here's our data. This is the same as in the first video. Our goal is to order numbers or sort them from smallest to largest, and this is our original data, right? So this is our original data, which means there's no pass here. A pass will represent once we run through a list once and get to the end, and we make changes and then have to go again another time. Each time we go through, that's a pass. All right, so you'll see how we record each pass here. So the first time through, when we're doing the selection sort, is we're trying to keep an eye on the smallest number and deciding if that's the smallest number or not. So right here, when we look at the 7, 7's our current smallest number, and I'm going to represent it with the paperclip. I move on to the next number because there is one. So is there another number? Yes. 13. Is 13 smaller than 7? No. Is there another number? Yes. Is that number smaller than 7? Yes. Okay, so this is our new small number. Is there another number that's small? I'm sorry, is there another number? Yes. Is it smaller than the 0? No. Is there another number? Yes. 13. Is it smaller than the paperclip 1, 0? No. Okay, is there another number? No. So then we're done. So that means after we're done here, we need to make a switch, right? That 0 needs to be added to the beginning. So that's the sorted part of the list. That's the beginning. And then all the numbers follow after that. So then a 7 would be dropped in its place, a 13, the 0. What did I do here? Let me see. No, that's a 92. So the 92 goes here. That's a comma, and then a 13. Okay, so that's what the list looks like after our first pass. So we applied the rules of the algorithm to this first list of items, and then this is what resulted. And now we're going to repeat again that same algorithm on this because we're not done, right? This is our sorted part of the list, and this is our unsorted. So there's still numbers that needs to be sorted. So we start again, but this time we start here because that part's already sorted. So 7 is our new low. Is there another number to look at? Yes. 13. Is that lower than where our marker is? 7? No. Move on. Is there something else to look at? Yes. 92. Is 92 smaller than the 7? No. Can we move on? Is there another number? Yes. Is that number smaller than the 7? No. So we must have, 13. Is there another number after that? No. So therefore, we identify the smallest number, and that's the 7. The 7 goes added to the end of the sorted list, right? And we identify this one as the new beginning of the unsorted. So we're going to go ahead and copy this down. So these two are part of that sorted list. These numbers right here are part of the unsorted list, right? The unsorted starts at 0. Okay, so that was our second pass. We're going to go ahead and continue. 13, that's our new low. Is there another number to check? 92. Is 92 less than 13? No. Is there another number to check? Yes. 13. Is 13 less than 13? No. Is there another number to check? No. We're done. So we found our lowest number, 13. So we're going to move that into our sorted part of the list. So these little lines just represent that it's this part of the sorted part. And that was what our third pass looks like. Okay, so now we're here. 92 is our new low. Is there another number to look at? Yes. 13. Is 13 less than 92? Yes. So that's our new low. 13. Is there another number to look at after that? No, there isn't. So that means we are done. We found the lowest number, and it's 13, and that needs to be added to the sorted pile there, the sorted list. And then on the 13, that's the one that appears next. And then the 92. Okay, that's what it looks like after the fourth pass, right? Okay, and now we're going to repeat again. 92, that's our new low. Is there another number to look at? No, there is no other number to look at. So what does that mean? It means we reached the end of our list and there's no more comparison or passes that are needed, which tells us that in our case, selection sort, right, took 14 passes in order to put the numbers in order from smallest to largest. And part of this will help you determine and decide if one algorithm is better than the other, right? Later on, you'll learn other algorithms that are not the selection sort, but a different one. And you can compare, is this algorithm better than the other? Or sometimes, does it matter? Why would it matter? The other important thing, most important probably right now, to take out of this video clip is being able to write down all these passes, because you might get a question on a quiz that'll ask you like, okay, you see this row, it's missing. What are the numbers that go in this row during the second pass? Meaning you'll have to be able to go from this set of numbers and fill in these in order to correctly connect to the next, right? Or maybe we give you these but leave out these right here, okay? Or we might ask you during which pass is 13 or 92, the 1, 2, 3, the fourth, I'm sorry, in which pass does 7 get moved to the second position? You would have to be able to identify that it's during the first pass, right? So that's just things that you need to be familiar with so that you can prove you understand the selection sort algorithm.